before the break, you go through example 1. You know that this question, you use a lot of integration and differentiation, and you have seen that the Newton equation of motion you cannot use because the acceleration here is not constant. Okay. Let's look at second example. Okay. Now, you have experience of solving this kind of question. So if you look at the question, it gives you a projectile fired vertically downwards. This means is that you look at the object. The object is moving in straight line or curvature motion. So this one, if you see that sensitive words, for example, vertical, upwards, and so on, this actually is chapter 1 kind of question. The object move in rectilinear motion, which is a linear motion, straight line motion. So it fall under chapter 1 kind of question. So as long as you identify the nature of the motion, then you can log into the certain chapter of this module. Then certain chapter have certain equation. For example, chapter 1 is like what I write on the whiteboard here. So this 4, definition of the parameter and the Newton motion equation. So this 4 plus this one plus this 3. So basically for chapter 1, you're actually applying this 4 equation plus this one plus this 3. That's it for chapter 1 kind of question. Right. So when you use this one, when the question mentioned acceleration is constant, then straight away you don't need to look at this one. Straight away you apply this. Okay. So the question tell you that into the fluid medium, initial velocity given, means VO is given. Due to the drag resistance, the fluid projectile experience a deceleration of A equal to minus 0.4 V square ms square. So sometimes when it comes to final exam, it will be a bit tricky. It do not give you the negative sign. It will use the acceleration with a magnitude of what, or a deceleration of A equal to positive value. Means when you do calculation, you need to substitute A with the negative sign. Okay, so this is a very kind question, but when it comes to final exam, there's a tricky question. You need to identify what is acceleration, what is deceleration. Again, acceleration in this module is a vector. So when you slow down, it means you have a negative sign already. It means you are reducing the value. All right, now determine the projectile velocity and position 4 seconds after it's fired. So you already know how to answer the question 1. For example 2, you should be able to answer also. So first, you identify the position or the reference. So in this case, you follow the bullet or you follow the projectile. Going down is positive. Okay, in the normal case, going up is positive, but in this case, we follow the motion. Go down is positive. So that in your calculation, everything is positive. We don't want to like make ourselves confused, right? Okay, how we start? Coordinate system. In this case, we follow the motion, go down positive. Of course, you can still stick to the statics, go up positive, but later, all the calculation will become negative, negative, negative. Right. So what we have, velocity. Initial velocity, we have 60. So you just copy. Initial velocity 60, acceleration is given in the polynomial equation, minus 0.4 V cube. Okay. So you need to determine the projectile velocity and position after 4 seconds. So in this case, acceleration is not constant because it's a polynomial equation. It's not constant. So this Newton motion equation cannot be used. So you need to derive from these 4 equations here, and even you need to add this one. Okay. So you start with the the one that you very close to. For example, this one the question give you the acceleration equation. So you start with the acceleration definition. You ask yourself, what is the chapter 1 acceleration definition? You write A equal to dv dt straight away. Then you compare to the question statement. A equal to minus 0.4 v squared. You have A and V here. And then through the equation you have here, you're actually linking the information here. A equal to dv dt. So if you differentiate this one, you're able to find the V, right? So your A is this one. A is this one. So dv dt equal to this one. So the next, you want to find the velocity, right? You want to find the velocity equation, although the initial is given, but you need to find what is the kinematics velocity equation. How the particle move, defined in the equation, velocity. So once you have this one, the next step is again mathematics. So you move the t to the right. This is a differentiation equation, but you want to find the velocity equation, you just integrate. Move your dt to the left, to the right. Then you see dv dt straight away at the integration sign. So integration sign. So in this case, you don't you just add in the integration sign, or in this case, let me see. Okay, this is another approach. So you move the okay. So why we cannot straight away add integration? Because this is v and not t. So when you do integration, try to group them in the same thing at the same place. So for example, v and v must put together. So if you integrate straight away, then you're going in the wrong direction. So remember to check before you integrate. The same parameter, for example, v in this case, v cube is on the right. You need to move them to the v parameter here on the left. So you move this one to the left, and then this one is t dimension. On the right is t dimension. On the left is velocity dimension. Okay. Why? If you stay this one on the right, when you integrate, you will not consider the time, the changes of velocity on the right-hand side. Because when you integrate, you look at the time dimension. Then you lose some information here. If you let this term stay at the right. Okay. So when you move this one here, 1 over something, expect to seeing ln or log equation later. 1 over something, and then you integrate it, then you get ln something. Okay. So here you get negative. Be careful on the negative. Always carry the negative along. So you integrate. Okay, you integrate here. Integrate. So this one, if this is for a better presentation, this is 1 over something dv. Then you integrate. Initial, initial given is 60, but general equation is v0. V0, v0 is 60. So you write 60 here. Then the velocity that you want to find, you don't know. So you put a v here. All right. Then right hand side, again, in front of the t, although there's nothing there, is 1. They always have one value here. 1. So you integrate this one, you solve this equation, mathematics steps, right? So you open up your mathematics steps. This one, again, we always pull the constant value out of the integration symbol. So for example, this one, minus 0.4, I pull the minus 0.4 outside. I pull the constant value out first. Then remain the parameter. So for example, the one that you see on the screen here. Okay. Once you do, if you're weak in this fraction form, you can change into exponential form. 1 over something, 1 over x, n equal to x minus n. So what you do, I always like to change the fraction into exponential form. In this case, is v minus 3. v power minus 3. Then I do the normal integration, like what I write on the screen here. If you integrate, then n plus 1 divided by n plus 1. That one, okay? So like what I show you on the screen here, I change the fraction into v minus 3. I see it as a linear form. Then I continue, do it. So when I do the procedure for integration, minus 3 plus 1, I get minus 2 divided by minus 3 plus 1, I get divided by minus 2. So I get this one. I get v power minus 2 divided by minus 2. And then I put a stroke here just to remind myself I need to substitute the value of my limit. So v minus 60. Okay. Then also on the right hand side also same. I put a stroke there to represent I need to substitute value later, t and 0. Okay, the rest is and here you can see that actually you're arriving at v equation, v equal to some t equation, right? So I'll continue. So here 0.4 multiplied by minus 2, negative, negative. At the end, you cancel out the negative sign. So you get 0.8 positive value. And this one, you just substitute v, you don't know. So you substitute v. And the minus 2, you already carry out already. So don't bother about the minus 2. Minus 60 power negative 2. Okay. Because you're substituting here, 60 minus power negative 2. Okay, then here t minus 0. Then you rearrange the equation in terms of, it depends on this question. This question asks you velocity. So you put in velocity on the left, v on the left, and so on. If the question asks you time, then you move time on the left. So, okay, the rest is mathematics. I'll just give you the full answer. So you move here and there, rearrange here and there, 0.8 move to the right. It will be 0.8 t. And this is, and then you move this one to the right also, then you get a minus 2, and so on. Okay. So you move this one to the right, it means 1 over minus 2. Okay. Now what does x minus n mean to you? This one is 1 over x power n. So if you move the whole equation, 1 over means is a square something. So for example, 1 over xn equal to something. Let's say I put a constant value 10 here. So how you balance this one? So what you do is that you move this one here and there. So xn equal to 1 over 10. 1 over 10 is minus something, right? So you want to take out the n, your x equal to square root of n 1 over 10, for example. So this means that 1 over square root of something. So I think it's better you write in the linear form rather than you write in a fraction. So if not, then you will be confusing on either you need to put on the top or bottom. So I highly recommend you put in the linear form, and then you proceed accordingly, right? So your v equal to this term, right? This term, v equal to something. The rest is just substitute the time inside the equation. Then you find the velocity at the 4 seconds after you fire. Right? Now, just be careful because you have a square something. When you have a square something, you have a positive and negative value. When you square something, you arrive at positive, negative something. Okay, of course, it's not x, it's something, the answer. Right? So just be careful. So in this case, positive root is taken. Why? Because velocity is a magnitude, is a vector. So you have two value of, when you press calculator, your velocity will have positive, negative. In this case, we take positive. Why? Because if negative means it go back, it pop out of the water already. It goes different direction. So it doesn't make sense, right? So velocity must be positive so that it follow the motion. Okay. So this is a reason why we take the positive root or positive answer of the square root when you do the square root here. Okay. Because you're dealing with vector, you're not dealing with the scalar or a simple value there. Okay. So your velocity you take as 0.0559 again for this module, minimum 2 decimal place, maximum 3 decimal place. Okay. This is for accuracy, 0.559. If your answer you put 0.56, also I give you correct. Positive go down velocity. So this is I just give you the illustration. So if you're lazy to put this mark, this direction mark at the back of your answer, you go to your free body diagram and put in the positive value go down. Okay, make sense? So that is the first part to find velocity. So this is the application of the question give you acceleration. So what you do, you recall back, okay, what is the definition of acceleration? It's the time differentiation of your velocity. Then from there, you derive. Then you see, okay, what you need to do. In this case, it's a time differentiation. So you do differentiation, then you come up with a new equation, and then substitute accordingly. One thing to remind in this example is that the square root kind of case. Square root, you always have a positive, negative solution. You need to look at the nature of the question. In this case, the bullet is continue to move downwards. So that's why you use a positive solution answer. Yeah. So unless the question asks you, what is the possible answer, maybe the bullet will bounce back. So you have two roots there. So in this case, you assume the bullet continue to move down. Okay. So once you find the velocity, then you go to the position. Right? Now, how you link position? Position is you have initial velocity, you have acceleration, and just now you have one more equation, which is velocity. You have one new equation you derived just now, right? But you can stick with the equation just now. A equal to dv dt equal to minus 4 dv v power square power cube. This one is from the question. I highly recommend you use back the information from the question rather than you use your solution in the question, rather than use this v equal to something. Why? You might make mistake in your calculation, and if you continue to use this one, the mistakes or error will snowball. So just be careful on that, right? If some of you ask, hey, sir, can I use this equation to continue to find my position? The answer is yes. But to have a safe way, you continue to use back the information here, and then you derive equation from there. It's a better, safer way. But if you're confident that your calculation is correct, you can continue to use the answer for the previous calculation. There's no like exact way to solve it, as long as you're able to apply the definition of acceleration, velocity, and displacement. Okay. So in this case, to find the position, what you do, recall back the A equal to minus 4v cubed. This one is given by the question. And recall the definition of acceleration with the time differentiation of the velocity. So what you do, you just substitute the velocity just now. Right? The velocity v equal to something. You substitute the v inside here. Then you arrive equal to equal to ds dt. Oh, okay. So this is actually is outside my screen already. So this is V. There's a V there. Just now you find the V just now, right? So V equal to ds dt. You have this equation. So you continue to apply ds dt equal to the previous one. This is from the previous answer, the previous section that you saw. V equal to something. So here you use a definition of V. V equal to ds dt, which is a time differentiation of your displacement. Okay, to find the position. So the rest, because you want to find the position, right? So you pull the dt to the right. When you do integrate, you find the displacement or position. Okay, you pull the dt, then you continue with the mathematics integration steps. Okay, so it's okay at this class you don't understand the steps here, because this one is your mathematics integration. This one, what is want you to take home is that you understand the principle of solving. Like, okay, in this case, what should I do? What should I do? It's not memorizing like the calculation here. The detailed calculation is your mathematics class. But what is important is, okay, what is the standard operating procedure? Like, for example, you call out the definition, then you run the integration or differentiation steps. Okay. So at the end, you substitute all the value at the end to find the displacement. This might look a bit challenging for you, but as long as you recall back how to do integration, you're okay. Okay, it might look a bit complex, but you're able to do it. As you do more revision or do more tutorial question, then you should able to do it, right? Yeah. So again, remember that it's not 0 in front of the ds, is 1 and not 0. Okay, then the rest is integration steps. Okay. Okay. So the rest you can work it out. You can work it out. Yeah. So from here, because you're dealing with something negatives there, you flip back, you go home and open up the general cheat sheet for integration. There's a general equation like what I write on the whiteboard here. Just refer to that, and then you will see that the steps actually. Okay, because we don't have time to explain how to do the integration steps. We assume you already know it. Okay. So at the end, you arrive at this answer. It's quite lengthy because of the nature of the calculation. So you just at the end you just substitute. You substitute. The answer for reference is 4.43 meter. Okay. So again, your answer can put minimum 2 decimal place, maximum 3 decimal place for this module. The important is the unit. So unit is important. So currently you are seeing the very basic unit. So when it comes to final, maybe we will not give you the ordinary unit. For example, we will not give you 10 kilo. We will give you like 10 megagram, 1 ton, a few ton, 10 ton, 5 ton. So you need to convert back to the kilogram and so on. Okay, so because this is the first 2 class, everything just to recap, help you to refresh back what you learned in the previous mathematics class, and then group back together, and then tell you the differences between static and dynamics. Okay, all right. Maybe this one more example. For example, now sometimes you look at a question without diagram. It just give you a statement, and then you need to draw the particles or the rigid body. First 2 example, you see diagram will help you, a very colorful diagram. But the example 3, you need to imagine or you need to draw the free body diagram. So if you see something like this, it means there's a mark for your free body diagram. So we take this one. During a test, a rocket travel upwards 75. Oh, so this equation, this one give you like one rocket, 75 move upwards. When it is 40 meters from the ground, the engine fail. So move up, 40 meter fail. So when the engine fail, it means we lose power. Lose power. So the velocity will drop, acceleration will drop, the displacement will also drop. Okay. Now determine the maximum height, denote by SB. So if the question already mentioned, you need to use a certain symbol, for example, SB, in your solution, please use back the SB. Don't use your own. If you write C or Q or P, then put question mark. What is that? Unless you explain in your answer. Okay. Reached by the rocket and its speed just before it hit the ground means the rocket will fly and then lose power and then continue to move, right? So rocket, when it lose power, you still continue to move because of momentum. So move up, then no more energy, it will turn back and come down. So the question will ask you, what is speed before it hit the ground? So there is a few phrases of analysis. You need to see it at a different time and different position. While in motion, rocket subject to a constant downward acceleration. It gives you this statement, constant downward acceleration. It means you can activate the Newton motion equation, these three. You can straight away use these three to calculate the downward acceleration. Okay, due to gravity, ignore the effect of resistance. So you will see the rocket from a starting point. So you draw the starting point. You draw like a dot also can. If you're good in arts, you just draw a cone also can. Important is your coordinate system. You always have a reference and then initial position and then what happened to a certain time. In this case, it's move up, right? Move up, engine fail at a certain location. It tell you at 40 meters from the ground. So you have your initial position and the last position for the first phase of the failure. So you just mark on your solution there, on your answer. You just put there is a position there from initial to a position A. Position A, engine fail. So one calculation for this one, and then another phrase, another phrase. So don't confuse yourself. As long as you have a clear diagram, you're able to solve. So velocity, it give you travel upwards, this one. So travel upwards, you have a velocity there. Okay. You have your S, displacement of 40 meter, displacement. Okay. Then the rocket continue. Even rocket fail, it still have momentum to move up until velocity at the maximum height. What is the velocity? It is maximum already, 0. So this is a hidden information. And if you're able to write this one, you get marks in your answer. You're able to draw a free body diagram and then you're able to think because you are at the degree level already. We expect you to do some thinking, not like a diploma or certificate level. So when you reach a certain height, no more energy, velocity 0. In your diagram or somewhere in your answer, you write V at a certain position or maximum, V max, V at position max equals 0. We will give you marks for that. It's not mentioned here. So when you give a conclusion out of the calculation, then you get the marks for that. Okay, so this one got mark 1. Mark 1. So degree level kind of question, you need to think a little bit compared to diploma. Okay, then you assume after V0, it will turn, the rocket will turn, then go down. So when it go down, it tell you already, constant acceleration, and you need to find velocity at this point. Okay, so if you draw the whole diagram, you can see that actually there are some missing information. Maximum position, you don't know. So from O to A, you know 40, but you don't know from O to B, you don't know. So the missing information is here. And then from here, velocity, you know, VB until here, you need to find the velocity at C. Okay, so before you move forward, check your free body diagram, check your coordinate. Is it anything missing there? Put all the information inside your diagram. Where is positive, where is negative? So for the first phrase, moving up is positive. For the second phrase, move down is positive. So don't confuse. Of course, you can have one general system there, but if you have one general system moving up positive, then C here you get negative already. Okay, let me show you how to do. Coordinate system, start from ground level, move up positive. Again, in this module, I highly recommend you follow the motion of the object. This object initially move up is positive. So my coordinate system before I start solving, from ground going up is positive. Maximum height, we don't know. But at the maximum height, we know that velocity is 0. Okay, so we know that upward velocity 75 positive. Why positive? Because it's follow the upward motion. Go up positive. So again, all the parameter that we use, velocity, acceleration, displacement, they are vector. Vector have magnitude and direction. So if you put negative, it means something already. It means opposite from what you draw in your free body diagram. Okay. So maximum height, we don't know, but velocity is 0 at that position. So for entire motion, the acceleration is negative 9.8 because there's a gravity effect. So why negative? Acceleration pull you down. So negative. Acceleration is a vector in dynamic question. So negative. So there are few hidden information here. One, velocity at B, 0. The acceleration is 9.81. For this module, we will use 9.81 rather than 10 meter per second square in your SPM or in your secondary school. For engineering question, I think for most of the engineering question, all the modules, you use gravity equal to 9.81 rather than 10, unless the question mentioned use G or gravitational acceleration equal to 10, unless it was mentioned in the question. If not mentioned in the question, then use the before. In this case, is given. So when it comes to final exam or test 1, test 2, if it not mentioned in the question, use 9.81. Okay. Equation to use in this case, these 3 Newton equation, you do shopping lah. You look at the 3 form, and then you choose which one to use. How you know which one to use? The question, what information you have? In this case, you have velocity, you have acceleration, and then you need to find the displacement. So for the first one, you look at the first one, velocity, acceleration, time. We are not concerned about time. So reduce this one. Don't need to look at this one. Second one, time. We are not interested in time. So second one is also not the option. So we only left out the last one. Last one give you velocity, acceleration, and change of displacement. This is what we want. Okay, so it's like going to shopping list and then you choose accordingly. For your assessment, test 1, test 2, final exam, general equation have marks 1. Even though you don't know how to solve, you memorize these 3, you go inside there, you write these 3, also get mark 1. Don't leave your answer blank. At least write something in your answer. Okay, so I already explained how to choose the Newton motion equation. Okay, the rest is just substitution and then find the answer. So in this case, this is a general equation. Then you apply according to the phrase. You have one phrase, second phrase, third phrase. You have one phrase, second phrase, third phrase. So you modify accordingly to your free body diagram. So first phrase is from, you want to find the from A to B. You want to find A to B because you don't know the distance here, right? You know the distance already, so you don't need to find lah. So you want to find the distance here, ma. So A to B. So you substitute. V is the final velocity. So VB, you know VB, right? 0. So V initial, in this case, you are looking at A where the engine failed. AC constant. S, this one is the final position, which is at the top or maximum position, SB, minus SA. So again, follow the question direction. Follow the question statement. In this case, it's B. It asks you to use SB, so you use SB. Okay, then the rest is substitution. Nothing complex here. VB, you know, is 0. VA, you know, is 75. And acceleration, again, minus 9.81 because acceleration pointing down. Acceleration is a vector pointing down. Your object, in this case, in particles, your particles is moving out. So you use negative. Then SB, you don't know. And minus 40. 40 is the initial position from the reference point, not 0. Huh? You always refer to the original reference point. In this case, from the ground. You're interested in the ground, from the ground. So here, SA is 40. Don't put 0. Huh? 0 means you're referring to this point. Okay, so if you look at this equation, it's a linear equation. There's only one unknown inside the equation you should be able to solve. This is a linear equation. Okay, you press your calculator, just be careful because some of you have a big hand, you might press the wrong small button on your calculator. Okay. At the end, you'll get SB equal to 327 meter. Of course, at the end, if you can write a 2 decimal place, also okay lah. Right? But in this case, yeah, it's roughly there lah, 327 point something or 327. Okay, so this is the idea how we use the Newton motion equation to solve projectile question. Okay, once you find your SB, the rest you can find also. Now the next one is velocity. How you find velocity before the ground? So again, you check lah. You check. So the third one, we're not interested in time. The first one, we're not interested in time. We're not interested in time. So you only have one more equation to use. Same. So same. So choose, go shopping, and then choose which one that can help us. If you use the first one, you don't have time, you cannot solve. Second one also, you don't have the time things to help you. It make you in a difficult position. The third one, you have all the parameters, just substitute, then you find the answer. Okay, so this example 3 is just to show you how to apply the Newton motion equation, these three big brother here. Okay, the rest is a substitution. VC, you need to find, because the question asks you velocity before it hit the ground. This one missing. VB, you already know, 0. AC was given, right? In this case, AC is, AC, let me see. In this case, I use negative. It's because I refer to the general going up, this one. But if you want to put it as positive also can, but you need to remember what happened if you use the positive value here. Means you are assuming the positive direction is going down. So here, if you see in my answer here, I put negative. It means all the motion going up is positive. Yeah. So you just need to be careful the negative positive sign because you are dealing with vector. Okay, in this case, I will get VC equal to negative. If I use all the general going up is positive, I will get negative 80.1 meter per second. Or if you put positive just now, you get positive value. It means it go down positive. So there are these two actually mean the same thing. It's only the general equation, the general direction that you use is a bit different. Okay, if you get negative vector, it means the general reference is all the motion going up is positive. Then you get negative means the velocity go down. It tell you the direction. If you get positive, it means you're actually looking at only this phase and the object is moving down positive. Okay, yeah. So for particles, you can break into this one, but when we come rigid body later, maybe after week 7, when you look into rigid body, then you need to take extra caution on the positive and negative sign already. Okay, because when it reach into rigid body, the reference, you can move your reference one when you come to rigid body. But for particles, we fix at one location. Okay, look at one location and then you fix it like going up is positive. Then the whole question also you move positive. You follow the general direction. Okay, makes sense, huh? All right. Okay, so the rest is just a side note on that. Okay. Okay, so I think we stop somewhere here. So next lecture, we deal with something called erratic motion. Okay, erratic motion. So we already cover a linear motion with continuous motion. Means the particles continue to move in a straight line. Next lecture or next week, we will look at it move, but then suddenly it stopped, and then it continued to move. Okay, so the textbook, they call it as erratic or changing motion. We'll cover that next week. Okay. Stop the recording. Remember to sign your attendance.